So this is a question. Design a 4x1 mux using 3 2x1 mux ICs. So first I've drawn whatever we have in a hand. That is, we have 3 2x1 mux ICs. These are all 2x1 mux, 2x1 mux, and 2x1 mux ICs. Okay, and this is my truth table of the 4x1 mux. This is what I require. This is what I have. So for each of the 2x1 mux ICs, I have two inputs, one output, one select line. Okay, so I0, I1, I2, I3 I am taking as the input lines of the first two 2x1 mux ICs. Then you have the strobe. Yes, this is your G bar. So G bar, and this is your G bar. Okay, so in the earlier case, when you were using an OR gate and a NOT gate, in that particular case, what were we doing? We were selecting one IC at a time. Okay, when the first IC was on, the second IC was off, because the output to the output of the mux ICs were going to an OR gate. So only one of the inputs should be legal or should be active for the OR gate. Otherwise, the other input would change the output of the OR gate. So only the output of the mux which we want, that output would go to the OR gate. But in this particular case, we don't have an OR gate. Instead, we have a 2x1 mux. Now, what is the role of this 2x1 mux? The role of this 2x1 mux IC is that this will select one of these inputs. Okay, since we don't have any of the gates here, what would this particular mux IC select? What should be the inputs to these two input lines? Because I0, I1, I2, I3 is already given here. So why do we need this mux? So while comparing with the earlier case, in this particular case, this is taking the place of an OR gate. But since it's a multiplexer, it is selecting one of the outputs. Okay, selecting one of the outputs means only one of the outputs is selected. But in the case of OR gate, the OR gate cannot select one of the outputs. So we have to keep one of the outputs 0 by making it inactive, by making the strobe signal 1 for that particular mux IC. Okay, but in this particular case, the multiplexer can select one of the inputs. So what we do is, if suppose this is my Y1 and the other one is my Y2, if this is my Y1, if this is my Y2, this multiplexer will select Y1 or Y2. Y1 or Y2. Okay, so this multiplexer will select either of the two multiplexer output. So that means that both the mux ICs can be active at the same time. You can have an output at Y1 and you can have an output at Y2. Which one do we need? That is decided by the third multiplexer. Okay. So when should Y1 be selected? When you need I0 or I1. So when do you need I0 or I1? The earlier case, when A equal to 0, you need the first IC. First IC. And when A is equal to 1, you need the second IC. Okay, that is, this is the case when you need y1, this is the case when you need y2. This is my y. So a equal to 0 means choose y1, a is equal to 1 means choose y2. So what should be the select line here? It should be a. A will decide on whether to choose y1 or y2. Okay, so we have selected y1 or y2. Now what should come in y1 or y2? How will we decide as to what should come in y1 or y2? That will be decided by B. Okay, which input line of each of the mux should be selected is decided by B. So we will just short these two select inputs. This is B and this is B, and we'll just short it with a wire and give this to a switch B. So A will select one of the output lines of the mux and B will select one of the input lines of the mux. So for all this to happen, all the multiplexers should be active. So for that, what should you do? You should connect all the G dash, all the 3 G dash to a single switch and keep it at low. So actually we need to short it. We can short it here, and we can short it here and give it as logic 0. Okay, so since it is logic 0 for all the multiplexer strobe, all the mux are on at the same time, and B will decide on which of the input lines should be selected. So if B equal to 0, I0 will come to Y1 and I2 will come to Y2. Okay, so let's see. When B equal to say 0, here we will have I0 and here we will have I2. And if A is also equal to 0, that means this particular line is selected, that is Y equal to I0. Just check whether it's right. A0, B0, I0. A0 itself, B equal to 1 means here I1 will be selected. And in the other case, I3 will be selected. I1 will be selected and here I3 will be selected. A equal to 0 means I1 will be selected. So 0, 1 is I1. Again, A equal to 1 and B equal to 0 means B0 means I0 and here I2. Since A is 1, the second line is selected, so this will be I2. If A is 1 and B is equal to 1, then here it will be I1 and here it will be I3. So here it will be I3. So 1, 1 is I3. So that is how you decide on how to formulate the circuit. You have to first analyze the truth table which we require, whatever components we have to use in the circuit, and then logically approach the question so as to formulate the design. And then finally just check whether your truth table and your circuit are compatible, if they are matching, if your circuit is giving your truth table. Okay, so that is how you give a 4x1 mux using 3 2x1 mux IC. Similarly, you can make any number of questions. We can go for an 8x1 mux using 4 2 by 1 mux ICs. Okay. Likewise, any number of questions you can formulate in the similar way. We just need to decide on what to give as the select inputs, whether you need to use any gates, etc. So that is another question in multiplexer. Next we have the demultiplexer. Demultiplexer is almost the opposite of a multiplexer. In the case of a demultiplexer, we have one input and many outputs, and select line and output relation is same as the select line input relation of a multiplexer. That is, if you have n select lines, then you will have 2 raised to n output lines in a demultiplexer. In the case of multiplexer, if you have n select lines, you have 2 raised to n input lines. Here you have only one data line or one input line. Okay. There you had only one output line. So in multiplexer, it is muxes many to one, many inputs to one output, and demux is one to many. That is one input to many outputs. Okay. So in multiplexer, depending on the value in the select lines, one of the input lines is selected and that will be propagated to the output. In the case of demux, you have only one input. It is either a 0 or a 1. So whatever data, suppose this is D, where D is equal to 0 or 1. That is, you are just giving this to a switch and you are placing that switch in some position, low or high, on or off. Okay. So this particular input will be propagated to one of the outputs, one of the many outputs, depending on the value of your select input. That is the difference between a multiplexer and a demultiplexer. In the case of a multiplexer, one of the input lines is selected. Whatever is there in that input line will go to the single output line. In the case of demux, the single input will be selected, will be transferred to one of the output lines selected. So here you will, suppose we are writing it similar to how we wrote in the earlier case. So this is O. Just to notate it as output, I have put it as O. You can give any name, O1, O2, O3. So this is my 0, 1, 2 and third. That is 4 output lines. And this is called as 1:4 or 1/4 demux. Demux or demultiplexer. Okay, so like in the earlier case, if it is 0 0 0 1 1 0 or 1 1, you have 4 output lines, that is O0, O1, O2 and O3. My input is D, where D can be 0 or 1. So if it is 0 0, where will that D go to? That will go to O0. So here this will get the D. 0 1 means O1 will get the D, others will be 0. D can be 0, but whatever is in D. Okay. And 1 0 means D2 will get the D, and 1 1 means O2 will get the D in this case, and here O3 will get the D. Now, in all the cases, what we do is, we will be writing the equation for the output line. Okay, so here we have 4 output lines. So you need 4 equations, O0, O1, O2 and O3. So what is O0? So when will we get something in O0? Suppose this D is 1. If it is 0, we can't see anything. So we'll write the equations assuming that D is 1. Why? Because if it is 0, then there won't be any difference in any of the output lines. Everything will be, all the LEDs will be off only. Actually, it is D only. If it's a 0 in the input line, you'll get a 0 only. But to write the output equation, we'll assume that it is 1. That is, if a 1 comes up, how do you get it? So O0 is 1 when A is 0 and B is 0. Okay. Or if this is D, you can say A bar, B bar, D. That D is the data. And O1 is, we get O1 if A is 0, B is 1 and whatever is in D will come. O2 you'll get when A is 1 and B is 0 and whatever is in D will come. And O3 you'll get if A is 1, B is 1 and whatever is in D will come to the output line. So here it is not in the SOP form, all are in the product form. So how will we draw this using logic gates? So here we have A bar, B and B bar. Then we have the input line, which is the D. Okay, so O0 is A bar, B bar, D. A bar, B bar, D. So what gate is that? AND. This is O0. A bar, B. A bar, B, D. O1. O2 is A, B bar, D. A, B bar, D. O2 and O3 is A, B, D. A, B and D. This is O3. So A bar, B bar, D, A bar, B, D, A, B bar, D and A, B, D. Okay. So this is 1/4 demux using logic gates. Right? So that is a demultiplexer. Likewise, you can draw for 1/8 demux, 1/16 demux. Any demultiplexer you can implement using logic gates.